All right, so this is the review for tomorrow's quiz. And we're hoping that the smartboard's going to cooperate. But anyway, here's what's happening. The math club was selling hot dogs at a school fundraiser. The club earns $108 and had a combination of $5 and $1 bills in their cash box. Here are some possible combinations listed in the table. So if there's 19 $5 bills and 13 $1 bills, you should see that 19 $5 bills, 19, whoopsie, 19 $5 bills, 19 times 5, plus 13 $1 bills should come out to be $108. And all of those combinations do. Now, there was a mistake on the notes page, depending on which class you are, but the last one that's highlighted should be 14 and 38. So find some more combinations, two more in particular. So think of two more values that when multiplied by 5, and then multiply by 1, add to give you 108. Here's one example. Let's say we wanted two $5 bills. That's going to give you a total of $10, right? Well, if I've got $10 and I need to get to $108, then if I say, well, what would then be $108 minus $10, and what comes out is 98. So if there's two $5 bills in the cash box, there better be 98 $1 bills in the cash box, because that's another total for 108. There's a whole bunch, or infinitely many, maybe not infinitely many, there's a whole bunch of combinations of ways to get $108 with 5s and 1s. Here's another one. Let's say I've got 8 $5 bills. That's $40. Well, the only way to get to $108 is to add 68 more dollars. So that means there must have been 68 ones. Okay, those are just two random values. You could choose anything you want. So how would we write an equation to simplify the above? Well, X are the number of $5 bills and Y are the number of $1 bills. So basically I can say, well, however many $5 bills I have, that's X. I'm going to multiply it by 5, plus however many $1 bills I have, I'm going to multiply that Y by 1. That has to total $108. 5x plus 1y equals 108. We can manipulate that any way we want and get it into y equals mx plus b. That would be an equation also. But we're not asking you to do that, but just in case we wanted you to graph this by y equals mx plus b, hopefully you realize that another equation that's okay would be y equals negative 5x plus 108. All you're doing is subtracting 5x from both sides. There's another equation that might work too if you wanted to, right? You could subtract, you could get everything in terms of x equals, and that's fine also. But I think the better equation right now is I've got 5x plus 1y equals 108. So let's use that equation on the next page. We know that we've got 5x plus 1y equals 108. Well, what does x and y stand for? Well, X is the number of $5 bills. So X equals number of $5 bills. Y equals number of $1 bills. Well, what is the number 1 signifiers? Whatever. So 1 is the value of a $1 bill. What's significant about the number 5? Well, 5, remember I'm looking at all these things. We just did X, we just did Y, we just talked about 1. Now we're talking about the 5. 5 is the value of a $5 bill. And finally, what's the 108 stand for? Well, the 108, that's going to be the total value of money in your cash box. Okay, so all of those pieces play an important role. So then it says, okay, well, can you graph that data? And the answer is sure. I could graph all those random points. Might be a little bit confusing. Or why don't I graph it just using the x and the y intercepts? That's okay too. So my choice, because there's a lot of ways to do it, but there's going to be, if I try to graph all of these points from the table of values, that might be a little crazy, right? I could, totally could, okay? But I'm going to go for the x and y intercepts, just a different way that you're maybe not always used to seeing. If I were to deal with x and y intercepts, that means if x is 0, what's y? If y is 0, what's x? Well, the easier of the two, the one that makes more sense, happens to be the x-intercept. Because if I were to plug in 0 for my original equation, right? If I were to plug in 0, what's 5 times 0? Well, that would be 0. Plus 1y equals 108. So that would mean that y is 108. In other words, if I have no $5 bills, remember these are the $5 bills and these are the $1 bills. If I have no $5 bills, then I'm going to end up with 108 $1 bills. Okay? Well, let's say if we go this way. Well, let's say I have no $1 bills. That means I've got a whole bunch of $5 bills equaling 108. And you might say, well, that doesn't go in evenly. And you're right, it doesn't. What comes out, though, is 21.6. Now, this would not make sense to have in our cash box. I get it, but I can still graph it. All right? So the idea would be down here, I'm going to have number of $5 bills. Over here, I'm going to have the number of $1 bills. This is always going to be 0. I need to go as high up as 108 on the y-axis. I need to go up as high as 108. So what if I make everything go up by tens? This is 10. This is 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. And I got to go over as far as 21.6 or 22 on the x-axis. I'm going to go by twos. 2, 4, 6, 8, 10, 16, 18, 20, 22. When I graph this, when x is 0, y is 108. So it's not quite up at 110, but it's somewhere about there. And when I graph the other one, when I go over 21.6, somewhere around here, I stay at 0. This is fine to graph your line. Okay? If you graph that table of values, you're going to have a much nicer looking graph, much more accurate. It's okay to graph it the way that I did as well. You only need 2 points, and I use it by the x and y intercepts. Alrighty. This goes back to the stuff that you said you guys all knew how to do, and I think that you do. So graph each line, identify a point that's in the solution and one that's not in the solution. So in this case, if I wanted to, I've already in y equals mx plus b. That's what's really important. So in this case, my slope is a half. My y-intercept is -3. I'm going to begin at -3. I'm going to go up 1 to the right 2. Same thing as going down 1 and to the left 2. And I'm going to graph my line. If I want to think about a point that is on the solution, I'm just going to pick this point right here. That point right there is 2, -2. So 2, -2 is a solution point. Whoopsie. And maybe I'll pick the origin, because 0, 0 is not a solution. Remember, it just has to be on the line to be a solution, not on the line to not be a solution. Let's try this guy. I've got to subtract 3x on both sides. 4y equals -3x plus 12. Divide by 4, divide by 4, divide by 4. Y equals -3/4 x plus 3. That's what I'm going to graph. I know that my y-intercept is 3. From there, my slope is negative. Down 3, to the right 4, plot my point. Or up 3, to the left 4, plot my point. There's my line. Let's pick a point on the line. I'm going to go for the y-intercept. It's probably the easiest one. So my y-intercept, 0, 3, that's a solution. I'm going to stick with the origin because that's not solution. Let's go to the next one. get this thing into y equals, subtract 5x from both sides, negative 2y equals negative 5x plus 8, divide negative 2, and I'm going to get the equation y equals double negatives, which is 5 halves x minus 4. This is the equation that we're going to graph. So when we graph it, I'm going to begin at the y-intercept, negative 4. My slope is 5 halves, 1, 2, 3, 4, 5 up, to the right 2. Definitely can't go the other way. So I've got 2 points, not a big deal. Well, let's see. A solution point, I'm going to go for this one right here. Solution, many of them, I'm going to choose 2, 1. Not a solution. I might as well stick with the origin because that's the one that seems to keep always working for me. Last one over for this. Subtract 3x, subtract 3x. Negative y equals negative 3x plus 2. Divide by negative 1. Remember, this is like a 1 attached. Divide negative 1, divide negative 1. Y equals, well, negative 3 over negative 1 is positive 3x, and then minus 2. Begin at negative 2. Up 3 to the right 1. I could also go down 3 to the left 1. Graph the line. Let's pick some points. I'm going to go for this point. So 1, 1, that is a solution. Does my origin still work for not a solution? And yes, it does. Not solution. Okay? Let's see what's next. Graph using a table of values. Well, we need to get into what, well, we don't actually have to get into y equals first. It depends if you want to use your graphing calculator or not. I'd like to use the graphing calculator. So I'm actually going to get into y equals minus 2x minus 2x, 3y equals negative 2x plus 12, divide 3, divide 3, divide 3, y equals negative 2/3 x plus 4. So when I find numbers in my table of values, I know that when I'm in y equals, I have to deal with this particular denominator. This denominator, if I want to graph integer numbers, I better use multiples of that denominator. Knowing that, and I'll show you in the table of values in a second, I'm going to see if I deal with multiples of 3. I'm going to do a negative multiple, which is negative 3. 0 is going to always work. And now I'm going to use a positive 3. Here's the calculator. I'm going to go to y equals, and I'm going to type in that equation. I'm going to type in negative, and it's going to be 2/3 or 2 divided by 3, my xt theta button, and I'm going to, what am I doing? Plus 4. I can take a look at my graph, no problem. There's my negative slope. But now if I go to my table of values, second table, I've got all these numbers that pop up. Notice how some y values are decimals and some y values aren't. It's the ones that are not decimals are the ones I want to graph. Here's the 0. There's the 0, 4. If I kind of go up, remember we talked about using multiples of 3, there's negative 3. So negative 3, 6, which is this guy right here, right? Negative 3, 6 I can use 0, 4, and I can use 3, 2. If you weren't sure which numbers to use for your table, get it into y equals, go to your table of values, and find the integers that you can actually graph. So I'm going to go back, and I'm going to say, alrighty, I saw that negative 3 came out to be a 6, 0 came out to be a 4, and 3 came out to be a 2. You could have totally plugged in those numbers on your own, multiplied the x, times the 2 and the y times the 3 and get those answers. Graph it. Negative 3 up 6 is here. 0 up 4, y-intercept. And then 3, 2 is here. And there's the graph. X, y intercepts, next one. X and y intercepts, I'm not going to worry about going into y equals. I'm just going to go into a table and I'm going to type in 0, or not type it, I'm going to write in 0, 0. If x is 0, then that means 6y is supposed to equal 100. Well, when I divide both sides by 6, I don't get a whole number. I get 16.6 repeated. That's okay. If I actually now use y being 0, then I get 10x equals 100. Well, this one is nice. What comes out for x is 10. Let me see if I can move this back. No, that's okay. I'll leave it over here. Okay, so I need to graph those points. So on my y-axis, I have to go up as high as 17, right? 16.6. I'm going to do that by going by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18. On my x-axis, I've got to go as far over as 10. Don't forget that's 0, 0. And then I'm just going to go by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, 0, 16.6 is somewhere around here, more than 16, less than 18. 10, 0 is exactly there. All I have to do is connect the dots. That's it. All right, last but not least. Now, the problem with this is the scanner doesn't work, so you will not see the graphs here. Sorry about that. But I'm going to do everything the same way. I know that the y-intercept, my b, the line crosses the y-axis on number 8 at -3. I know that my slope is positive. If I start counting from one point to the next point, I have to go up 1 and to the right 5. So the equation should be y equals 1/5 x minus 3. Graph number 9, my y-intercept. I crossed the line, I crossed the y-axis, sorry, at +3 this time. My slope, by looking at my line, I know is negative. As I count down from point and to the other point, I go down 5 to the right 5. This does simplify. So this equation would be y equals -1x plus 3. Last but not least, number 10 is my y-intercept. I begin at the origin. My slope is positive. I can see that from my graph. As I count from point to point, I go up 4 to the right 3. My equation equals y equals 4/3 x plus 0. And no, you don't need the 0. If you want to write the equation a different way, you can just write it as y equals 4/3 x. Either one is fine, okay? So you should be all set for tomorrow's quiz. It's very short, so I say it is very short, and I think you should be fine. Good luck.